Hey everyone, welcome back to my channel. Today we are gonna solve a medium question on lead code, longest nice subarray. Let me read the problem statement. You are given an array nums consisting of positive integers. We call a subarray nums nice if the bitwise and of every pair of element that are in different positions in the subarray is equals to 0. If so, return the length of the longest nice subarray. And subarray of length 1 are always considered nice. Okay, Let, let's take one example and try to relate to the problem statement. So here we are given integer array. We have this, and the output says that the longest subarray, which is nice, is of length 3, right? How? Uh, if we take this one, it can the end of these three is one because the one bit is both common in one and three, so it cannot be a subarray. So maybe we'll have to start from here. And this can be a, if we write down 1, 3, 8, 48, that's 10. This will equals to 1, 0, 0, 1, 1. Let's take only three numbers for now. So this will be 0, 0. Okay. If we do AND for these first two numbers, uh, there is one common bit because AND of 1 and 1 is 1. So we cannot having a subarray with this one. And if we take these two array numbers, there were no single bit common at any position. So the AND operation, bitwise AND operation of 3 and 8 will equals to 0. And likewise, if we take 48 as well, uh, the representation of 48 can be, uh, it can be anything. For, how can we write 48? We have a 2, then 24, then 12, 16, 32. So this is 8, 16. So this is 16, this is 32. The remaining is 8 plus 8, which is 16. So if we take AND operation of these three numbers, there is no common bit among them. Uh, so if you take any pair in between, there is no position where it has one as a set bit. Uh, so 3 is the answer for this one, right? So the important observation we can make key point is if the bitwise AND of any two numbers it should be equals to 0 if and only uh, if there is a 1 present at any position uh, in one number, then another number we cannot be having a set bit at that same position. So see, ith position can have only one set bit of given number, right? Uh, so that is one position. Based on this observation, let's try to solve this problem. Maybe we have one initialize one number and we'll try to do AND operation. If it is equals to zero, what we can do is since these two are equals to zero, we have to have a new number that is having all the set bits. How we can get is uh, if you want to know, so after this operation, we will be having something like this. We need this kind of thing to track, right? We can do an OR operation to do that. And since we are having only set bit at only if we have set position at ith position and in the another number at a same position, there won't be zero. There won't be set bit. Based on this principle, what we can do is we'll keep doing AND operation and we will be storing this as OR operator. I'll try to show one example. And whenever if it is not zero, let's say this thing, we'll have to undo this, the last one, and we have to shrink towards right. So if we do XOR of it, so XOR of same number will resultant into zeros. So this number is already part of that number, that window. If you do XOR of it, it will got cancelled out. So we will be doing three bitwise operations and OR and XOR. Uh, Maybe I'll try to code this up. Maybe you'll get some understanding. Uh, where size is equals to, and we will maintain if subarray of is which is not equals to zero, we will have to undo nums of left, and we will have to string the array towards the right, right? Uh, upon at some point, this will get leads to zero. Then longest nice. Maybe we'll just call it as a result for now. And then I will return the result. And this result is equals to math dot max dot result, comma, right minus left plus one. The window size will give us the length of the subarray, which is equals to zero. And what else we are going to do is we will have to we'll have to uh, save the bits to do the next operation to check the null uh, on the right side. So that will be summary of our nums dot right? Right, CHT. So this is the implementation. Let's try to submit it. Okay, let's try to analyze time and space complexity. Uh, we are running a loop till the size of the array, and inside the loop, this will get string up to right. So at max, we are uh, exiting each element in the array twice. As right going to the right towards the end, and this left will string whenever it is not equal to 0. And but this left does not cross the right. Once this left moves to the right, it will not reset it anyway. So it will be like 2 times the size of the array, but we can consider a big of n. And space complexity, we are not using any extra space, only the constant space here. So it will be big of 1. Let's try to submit this problem solution and see. Got it. So it got accepted. Uh, the pattern we are using is sliding window. If you don't watch my previous videos on sliding window playlist, please go through that. Where I will be using the same template where we will be having left and right, and this right loops run, and inside it, until it is not valid, we will be shrinking it, and if it is a valid, we will be storing the answer and keep moving, keep extending the window. This is the pattern for sliding window. And thank you for watching the video, and please like, share, and subscribe to my YouTube channel. And see you next time. Bye.